Good day, students and viewers. My name is Abdulaziz Idris, and here is our continuation of the last video. So, in this example 2, we are asked to use the principle of mathematical induction to show that n raised power 2 raised power n is strictly less than 2 raised power of n plus 1. So we test that for n equals to 1. So you see, for n equals to 1, so P of 1 is saying that 2 raised power 1 is strictly less than 2 raised power of 1 plus 1. And this is equals to what? 2 raised power of 2. So we see that 2 raised power 1 is strictly less than 2 raised power 2. What we mean here is that 2 is strictly less than 4, and it is true for n equals to 1. Since it is true for n equals to 1, we can just assume it is true for all n and then prove that it is true for n equals to n plus 1. Of course, so we just go and say P of n plus 1. What happened in the P of n plus 1? So if this is n plus 1, what do we have? So we have, so for us to prove that it is true for n, so you have to prove that it is true for 2 raised power of n plus 1, 2 raised power of n plus 2. And to prove this, we easily multiply both sides, by 2. So if this is equation, let's say this is equation 1, the inequality 1, so we multiply both sides of 1 by 2. So what happened? So we take this, so we have 2 raised power of n times 2 is less than 2 raised power of n plus 1, and then by 2. So this gives us 2 by law of indices, because we have equal bases here. This is n and then plus 1, because the numbers are equal, they have equal bases, so we simply add their power. 2 here is power 1. So actually, this is less than 2 raised power of n plus 1, and then this has power 1, and it is equal bases, so we have plus 1. So this is equal to 2 raised power of n plus 1, strictly less than 2 raised power of n plus 2. So we see we have started 2 raised power of n less than 2 raised power of n plus 1. So when n is equals to n plus 1, we have 2 raised power of n plus 1. N is n plus 1 to 2 raised power of n plus 1 plus 1. So we have 2 raised power of n plus 2. And by the principle of mathematical induction, we see that P of n is true for all n. For all natural number n. In fact, this is the proof. Thank you very much.